If there's anybody that didn't come and get it, we'll be down here. The final, next time we'll see each other, last time, will be next Monday, a week from now. So you have a week to stress/relax. Take your pick. Right here, we'll start a little earlier though. It begins before this class time. Jeff, you can come get your paper if you'd like. Any questions about it?
Still allowed an 8.5 by 11?
Yeah, you can still have one 8.5 by 11 sheet of paper as a cheat sheet and a calculator, yes. It's the same format, same style as we've been doing. There'll just be 60 questions since we have more to cover. But be grateful and see we had 5 units, each 30. At least there's not 150 questions. So in 2 hours for 60 questions, most people feel like it's enough time to address whatever they need to. Of course, you know, there's always somebody sitting there till the bitter end, and that's fine. Well, I'm trying something new here. Other people have done this before. A colleague of mine's done it. So I came up with 51 questions, which we obviously won't have time to get through all of them, in Jeopardy style, except for you don't have to form the answer in the form of a question. I just kept them as multiple choice like we've always done. So when that one comes on, I have 2 rounds. Round 1 has 5 categories. It's like the first half of the semester, and round 2, the second half. Which one would you like me to start with? Because it's older? That's what I was thinking. And we'll gauge time. If you feel like we should just switch to the second one even though we haven't finished round 1, I'm okay with that. You just shout it out, and if I'm getting a lot of feedback, that's great. And then I do have a final Jeopardy question that we might just skip to or never get to. So the way I thought we would do it is we'd split teams. How about team 1, team 2. Somebody will choose a question, you know, you'll choose it, category and question, and then it's open to the whole class. And you guys can discuss amongst your teams. That's perfectly fine. And then the first person that raises their hand that I can notice, forgive me if I get it wrong, has a shot to answer. You have but I'm going to read the question first. As soon as I finish reading the question, that's when you can start raising your hand. Just so we have a starting point. So I'll read the question. As soon as I finish reading the question, first hand up, you'll get a shot. If you get it right, you have 3 seconds to answer. Once I call on you, and you get it, you'll get the points. If not, the other team gets a shot. If you get it wrong, I'll just give you the answer, and we'll move on. And then someone new will choose the question. If you answer, I'll toss you some candy if you'd like. And unless it starts getting dangerous, then I'll just have you come down. Okay. Let's see. Did we come up? Gotta have the music, right? So those of you that just came in, feel free to come down and get your papers at some point. And we're going to review with Jeopardy here. Review for the test. Gotta have the music. It's alphabetical, so you're probably over here under A. There you are. Okay. Here's the categories. I just split up some kind of the chapters. So you can see chapters 1 and 2, and 3 and 4, 5, 6 and 7. You can read it. You can just shout out the category and the amount. All right, why don't we start with team 1. Pick a category. Category 1 for 300. Question is, a sheet of paper can be withdrawn from under a container of milk without toppling it if the paper is jerked quickly. This best demonstrates that. Okay. Oh, you know, I forgot to make this go faster. The answer, so I don't have to Just a sec. There we go. Just for so I can be watching you guys instead of concentrating. Okay. Correct. Oh, and you get something for answering, Stephen. Here you go. So team 1 gets that was 300, right? That it has inertia. I was pulling the tablecloth out from underneath. See, I have the answer there, but I want to know before I show you without thinking. Okay, so team 1 gets to guess again. You can pick a category.
Category 3 for 300.
3 for 300. Newton's third law for 300. Let's see. An automobile and a baby carriage traveling at the same speed collide head-on. The impact force is?
Same for both. C.
The same for both. C is correct. Catch. 300 for you guys, right? All right, so your team gets to go. Let's start with Jeff, and we'll work our way.
Category 2 for 200.
Category 2 for 200. A ball tossed vertically upward rises, reaches its highest point, and then falls back to its starting point. During this time, the acceleration of the ball is always?
D.
He goes with D. That is correct. It's always directed downward. At what value?
10.
That's right. You want a Tootsie Pop? All right, that was 200. Let's do that. As I was writing these, I was like, hey, these are the same questions we asked before. Remember when they were hard? You can feel good. Okay, your team, so you can pick one.
Let's go category 5 for 400.
Category 5 for 400. A woman standing on the ground sees a rocket ship move past her at 95% the speed of light. Compared to when the rocket is at rest, the woman measures the rocket's length as, and I saw your hand first.
B. Shorter.
B shorter. Correct. That was 400. Keep me honest here. All right. Pick a category.
Let's do category 2 for 300.
2 for 300. An object at rest near the surface of a distant planet starts to fall freely. If the acceleration there is twice that of the Earth, its speed 1 second later would be. He goes with B. You know, I got to keep track better where we're at. That was category 2 for 300. Correct. Wish me luck. Wah. 300. You're on this team. All right, so we go back to this team. Let's see. Hey, you came in. You can pick the category.
Okay. Category 5
Okay.
for 100.
100 it is. Read the question first. Roll a bowling ball off the edge of a table. As it falls, its horizontal component of velocity does indeed remain constant. I don't know, I'm randomly picking here. That was 100. So back to your side, Candelaria. I'm putting you on team 2, unless you want to be on team 1. You pick the category.
Okay, category 4
Okay.
for 200.
4 for 200 it is. A heavy truck and a small car rolling down a hill at the same speed are forced to stop in the same amount of time. Compared to the force that stops the car, the force needed to stop the truck is? I saw your hand first.
Your first.
You argue it out.
A greater.
Very good. Catch. That was. Thank you. 200 over here. Didn't realize there was this many things to keep track of. So over here, you picked one, right? Let's do Stephen.
Let's do category 2 for 400.
2 for 400. Maybe if I put the chalk there, I'll remember. A 10-kilogram brick and a 1-kilogram book are dropped in a vacuum. The force of gravity on the 10-kilogram brick is? I think I saw Madeline's first. Megan. Yeah, sorry. A the same is not correct. Team number 2. Yes. B? Correct answer is B. The force is larger. What is the same? The acceleration. That one gets confusing. So 400 over here. But you both answered. Sorry. Here you go. You want some? Oh, okay. You want some? Yeah, it gives you something to do when you find it. Okay, back to this side. You're on that team, so
Let's go category 1 for 500.
just use this as my 1 for 500. A package falls off a truck that's moving at 30 meters a second. Neglecting air resistance, the horizontal speed of the package just before it hits the ground is? About 30 meters. Answer C. Nicely done. So that's 500 for this team. Okay, we're over here.
Let's do category
3
3 for 500.
for 500. You got it. The force that accelerates a rocket in outer space is exerted on the rocket by the exhaust gases is correct. Now, we've gone a ways. If any of these really confuse you and you want to discuss them, tell me, okay? We don't have to just blow by these. This is a way of reviewing and whatnot, and you know if it's confusing to you, you know where you can go look, but I'm happy to give you a little explanation if you want it, okay? Yes?
So on this one, it's the force pushing from the exhaust gases against the actual rocket, right?
Yeah, the rocket pushes on the exhaust gases, so the gases push back on the rocket, and that's the force on the rocket that actually propels it. It's Newton's third law. Okay, you got it correct. It's all. 5 and 5. When a blinking light source moves relative to you, the speed of the light way in the back.
Is it B?
Let's see, shall we? You're right. It remains constant. The speed's constant, but the frequency can shift. And you can come at that two ways now, through the Doppler effect or relativity. Because those wavefronts are intercepting your ear. Your ear is intercepting the wavefronts more frequently. But we're not changing the speed of light. Good. Okay, that was Wish me luck. Oh, nice catch. 500 over here. Okay, we back this way. 4 for 500. I tried to put harder ones I thought were harder on the end, but forgive me if they're kind of... It's a game. Both a 50 kilogram sack is lifted 2 meters from the ground, and a 25 kilogram sack is lifted 4 meters in the same time. The power expended in raising the 50 kilogram sack is... Blue pants. See the same. Very good. Quick thinking there. What's work? Force times distance over the same time. Energy over time is power. Yeah, the product's the same there. Good. All right. That wasn't bad. Okay, that's this side. That was 500. So back over here, where did we leave off? Got him. Yes. 2 for 500. Suppose a particle is being accelerated through space by a 10 Newton force. Suddenly the particle encounters a second force of 10 newtons in the opposite direction from the first force. The particle, with both forces acting on it, I saw your hand first. 1. Okay, that is correct. This one makes sense? So 10 newtons one way, then all of a sudden 10 newtons the other way. What's the net force? It's now 0. So it no longer accelerates, and accelerate means change its velocity. So it'll just keep going at that speed. That 10 newton doesn't stop it. Its inertia keeps it going. It would need more than that 10 newtons to slow it down and stop it. Does that help? Okay, now I just talked too long. Who answered? You did. And that was 500 for this team. It's this team over here. That one. 1 for 400 it is. When a rocket ship accelerating in outer space runs out of fuel, it... One, 2, 3, and... A is incorrect. So back to this team. I saw your hand. C is correct. But you guys answer. You tell me when you do. And let me get the points. That was 400 over here. While you guys are thinking. So again, if the force is removed, it doesn't just stop. Inertia keeps it going at whatever speed it's at. It can't change its motion anymore because no force is no longer applied. There's no acceleration, it keeps going. Does that help? We're on this side. Three for 200. As a ball falls, the action force is the pull of Earth on the ball. The reaction force is the, way in the back. Earth pulls on the ball, ball pulls on the Earth. Very good. So that's 200 over here. Big money now, right? Catch. There's a little one. Ooh, nicely done. And over here, help me where we left off. You guys did it, right? All right, on your laptop, it's your turn. Would you like to pick a category?
I'll do category 2 for 1.
A car maintains a constant velocity of 100 kilometers an hour for 10 seconds. During this interval, I must finish the question, during this interval, its acceleration is. I don't know, Patricia or you? I couldn't tell. We'll go with Patricia. Way in the back. A is correct. It's kind of a trick question. 10 kilometers an hour, 10 seconds, but it's constant velocity. It's not changing. That was 100 over here. Oh, right, Patricia. I'm going to hit the projector. If we start getting dangerous, I'll just have you come down. All right, so we're over here. Next row in the jacket. You can choose, yes. Three for 400. Find my cursor, there it is. Let me read it. A car traveling at 100 kilometers an hour strikes an unfortunate bug and splatters it. It helps me if you don't have your hand up till I know it's tough, but because the force of impact is. That's always fun. I saw under the window there. C. That's right. Same force has a larger effect on the bug because it has less mass. Oh, sorry. That is 400 over here. Yeah, the rule is I got to finish it first because I can't watch and read. So, yeah, and aside from setting up buzzers, I'm sorry.
I got a question.
Oh, yes.
So the acceleration would be greater on the bug, right?
Yes, they'll feel the same force, but because the bug has less mass, less inertia, he'll accelerate more. The bug can't withstand that much force where the windshield can. But it is the same force on each of them.
So is it just like it's big A on the windshield, little A?
Exactly. Big, or the other way, big A, big acceleration for the bug.
Yeah.
Little acceleration for the car. Yeah, that. Same force, so little one gets big A, I guess. And big mass, little A, for that same force. We're over here. Eddie, I think it's you. Yeah, I gave you team 1. You're kind of in the middle, so I picked.
4.
Okay. Whoa, daily double. Did you get it right? Whoever gets it right, twice the points. 2 billiard balls having the same mass and speed roll towards each other. What is their combined momentum after they meet? I saw that hand.
0.
He's going with 0, which is answer A. Correct. Tell us why.
Because they're in the same mass and have the same speed, so when they connect to each other, they cancel out.
Because they're coming in opposite directions. They both have momentum, but one's positive, one's negative. So the total momentum is 0 to start with. So the total momentum has to be 0 afterwards. Since they're the same mass and speed, you know what will happen to them. They just stop moving. That was 300 plus 300, 600 over here. You guys are doing well. Okay, that was back over here. Where did we leave? 4 for 400. A bow is drawn so that it has 40 joules of potential energy. When fired, the arrow will ideally have a kinetic energy that is Itzel. C is correct. Conservation of energy, 400 points to team 1. Oh, if I forget and you want it, just holler. See, I'm proud. Look at this. You guys went for the bigger money ones. See, it's all about the money. Okay, we're over here. So we did Eddie. Devin. 5 for 300. Where's my cursor? There it is. A hunter on level ground fires a bullet at an angle of 10 degrees above the horizontal while simultaneously dropping another bullet from level of the rifle. Which bullet will hit the ground first? Way in the back. I can see everybody, Candelaria. His was up first. Sorry. That is incorrect. Who was over here? Okay. Which is what? C was what he answered. So that's both incorrect. This team. Let's get somebody then so you don't have to fight it. A is correct. Now let me get everybody while you're thinking about it. Way in the back. You ready? You paying attention? Hello? You want to catch? Before I bonk you in the head. And here you go, Lara. Okay, the one that shot up, what you're all thinking, or the monkey shoot. If you shot it level and dropped, they would hit at the same time because they both fall vertically the same distance. If one is shot up, though, it takes time for it to go up and back down to that same initial height, then it falls. So it's in the air longer. So the one that's dropped will hit the ground first. Does that make sense? I haven't given money yet, have I? 300. Who finally answered it over here? So we're over here. Yep. Thank you. 5 for 200 it is. A gun with a muzzle velocity of 100 meters per second is fired horizontally from a tower. Neglecting air resistance, how far down range will the bullet be 1 second later? What is C? I like it. That's correct. If it's going 100 meters per second, what is its horizontal velocity the whole time? 100 meters. Horizontally, it doesn't change. So in 1 second, it'll go 100 meters. Very good. That's 200 over here. Grab something for you? Okay. One for 200. In science, the theory is, I saw that hand. 1, 2, 3, and going with C, just in the nick of time because I'm nice. You're right. Yeah, a theory is a well, there it is. That's synthesis. So just in the nick of time. 200. Want some more? Okay. Back over to here. It's your choice. It is correct to say that impulse is equal to, I saw your hand. A, incorrect. B, correct. Yeah. It's not just momentum. Momentum and impulse are different, but impulse is a change in momentum. It requires a force to change that motion. So, all right. Want some? Itzel? And that was 100 over here. What's that? Should it be reworded? It's back over here. Yep. Okay. 1 and 1. In science, facts. May change. Answer B. Correct. Yeah. So facts, but if we learn new stuff, you're absolutely right. We'll change them. Scientists should not be stubborn, although I know several. And you obviously get this, everybody gets this one. Here we go, category 3 for 100. A karate chop delivers a blow of 3,000 newtons to a board that breaks. The force that acts on the hand during this event is, I saw your hand first. 3,000, answer C, correct. It's Newton's third law, action reactions. 100 over here. Good, hey, we made it through a round. Here's some dots. What'd you think? Is it helping? All right.
So how does the hand survive the 3,000 newtons of force?
Some hands don't. Some hands don't survive 3,000 newtons of force. But that's if it takes 3,000 newtons to break the board, that's the force the hand has to exert on the board. If that's going to happen, the board will exert 3,000 newtons of force back on the hand. If your hand has not been trained or you hit it improperly, it will break.
So there's no way of cheating it?
No, there's no way of cheating. The way they do it is training. You hit it correctly. You don't want to like, and this part's better than this part, and stiffen it up, and you can practice and get stronger. But no. There's some boards that'll break easier along the grain, but then it doesn't take as much force. So you don't feel as much force. Number 2. All right. Done with that one? Got here. These are the next categories. How we doing? Pretty good. Good enough. All right. Who's ahead? You guys? We'll let you choose first then. Where do we leave off? I think we're, yeah.
Let's go with category 2 for 200.
That's where my candy was sitting. All right, we'll do it. Category 2 for 200. Cold water will warm to room temperature faster in a, I saw that hand. Black pot, answer A, correct. Ready? Close. 200 there. Black absorbs all the colors, all the wavelengths, so the internal energy increases. That's over here. Where do we leave off? Your friend. I can't see his face.
500.
Oh, so category 1 for 500? Got it. An umbrella tends to move upwards on a windy day, principally because, okay, Itzel, 1, 2, you're right. The air pressure is reduced over the top curved surface. What principle is that? Good job, Bernoulli. So 500 over here, it's 54. Want some more, Itzel? Okay.
Category 3 for 400.
3, 4. A man named Caruso is said to have made a crystal chandelier shatter with his voice. This is a demonstration of? D. Resonance, absolutely right. You're driving it at its natural frequency and see if it breaks. 400. Want some more?
Sure. Why does the glass doesn't resonate like crystal does? Like, would you like to see?
Yeah, glass, there's lots of ways they make glass. Beakers, fancy chandeliers, fancy wine goblets. It's how they form the glass in the first place. That crystal structure. So it changes how well it absorbs different frequencies. You know the ones that you hit and they go bong? Those are good ones. Those are ones you could probably shatter easier. Ones that you hit and kind of go thunk don't vibrate naturally as easily. So it'll take more energy to do it.
So it's just the visual structure of the glass.
That's right, yeah. Because what's resonating, why it vibrates, is that internal structure. If they're free to vibrate more freely. I know that was redundant, but you know what I mean? That was over here. Where are we at? Help me out. I think it's Ina, right?
Category 4 for 300.
You got it. 4 for 300. Color seen on a TV results from color. I saw Itzel's hand first, I believe. Addition A. Yep. It shines light out. So we're adding light. 300 over here. Tell me if you change your mind about candy. So over here, way in the corner. 5 and 5. Go for the gusto. This electricity stuff. When two lamps are connected in parallel to a battery, the electrical resistance that the battery senses is? Incorrect. A. Incorrect.
B.
P. I guess there's 3. I'm not going to give you points. But let me catch up with Candy. Want some?
Can you explain that?
I will, yeah. Absolutely. And you were first, Stephen?
You had an experiment here with the lamp.
All right, when two lamps are connected parallel in a battery, first of all, that tells me the current can split. It has 2 paths to take. The electrical resistance that the battery senses is. Well, if it has 2 paths, it's easier to get through than if they were in series with each other and it had to get through one and then the other. It's like a big longer wire. So think of 2 in a row as one long wire and you have to get through all of it. Where if you put it in parallel, it can split. Some of it can go this way, some of it can go this way. It's easier. There's less resistance. Yes?
Doesn't it just require more energy?
It would require more energy. Because there's less resistance, more current can and will flow from the power supply if it's strong enough. Thus, more current will flow out of the battery, the power supply, but it'll split. And that means more power is being used. Yes, Eddie?
Yeah, look on that point, I found that a little confusing in that in parallel, you're saying because there's more paths, there's less resistance. And wouldn't the sum of resistances still total resistance?
Yeah, the total resistance, the sum of them, is less. If you're just looking at the battery, what the battery sees, I'm trying to try to get from this terminal to this terminal, and I have to go through all of that to get back. So it sees it all as one big resistor. If there's multiple paths, it sees the sum total resistance as less because of those different paths than if they were all in series. Notice we're not changing the individual resistance of the resistors, but how you arrange them can affect what the battery sees, the power source in the first place. Does that help?
So if you had a current going through all these outlets, this one would have more energy than that one.
If I had current going through all these outlets, this would have more energy than that one. I'm not sure how to answer that because these are what's providing the power. If these were resistors,
Current going through them all, right?
no, not until you plug something in.
Oh, okay.
This is kind of like, it's like it gets those 2 sides. The potential difference, the electric potential, which is voltage, it's 120 volts on the high side, 0 on the low side. It's waiting. And once you plug something in, now it gives it a path. It can see that electric field, which will get the charges that are already there to start moving. So yeah, there's like a line that goes to all of them. We get 120. It was like my rods. We had the lab stand and the lab stand. It was like there was 12 volts here, just waiting, and 0 over here. And as soon as you plug something in, oh, here's a path. I can do it. It'll flow. So yeah, since there were only 3, I'm not giving you credit, but good job. I think this team had the last correct one, so We'll let you choose.
Category 4 for 400.
4 for 400. What is the wavelength of an electromagnetic wave that has a frequency of 100 hertz? And there's the speed of light. B is incorrect. This team. C is correct. The easiest way is, see that relationship? Here's the speed of light, of the wave. I gave you the frequency. So 300 million meters per second divided by 100 hertz is 100,000 meters would be the wavelength, actual wavelength. Yes?
So, what are the units for hertz again? Is it
Yeah, hertz are cycles, revolutions, repetitions per second, inverse second. Remember the period's the flip of that, how long one of those cycles takes. Who got that? I forgot. Help me out. Who answered it? Thank you. 400. You want more candy? Okay, back to the front. 2 for 500? If a solid object radiates more energy than it absorbs, it's... Say again? B is incorrect. C is correct. If a solid object radiates, gives off more than it absorbs, its internal energy decreases. Now the catch is B could happen, but it's not a guarantee. C is definite. The internal energy has to decrease, right? But remember, you can have a change in internal energy and not affect the temperature. Like if it's having a phase change or it's going into, if it goes into anything other than average translational kinetic energy, then the temperature wouldn't be changing. So a little subtlety there. Who wants it? You're good? Patricia. So 500 to, man, I'm getting bad. Was that over here? We're getting to the end. How about one more and we skip the final Jeopardy? So we're over here. You get to pick.
How about light, category 4 for 500?
4 for 500 it is. The redness of the lunar eclipse is evidence for the... Are you going? Okay. B is incorrect.
C?
C is incorrect.
D.
D is incorrect. A is correct. Okay, raise your hand if you answered and won candy. Careful. I missed, totally missed. You can come down and get something afterwards. You want to switch? You want a Tootsie Roll? Here, come switch. So the lunar eclipse, I don't know if you remember, that's where the Earth gets in the way, but some of the light refracts and bends through the atmosphere and lands on the moon. And since it went through all the atmosphere, the higher frequencies, blue, got scattered out, and it's like all those sunsets landing on the moon. So it's a refraction of that light. Does that make sense now? So it's just the sunlight going through and around the Earth and getting refracted through our atmosphere. That blood moon we see, that's what's going on. Okay, let's skip to Final Jeopardy. So the way this works, if you remember, there it is. You guys have to talk amongst your teams. How much are you going to bid? if you get it right. If you get it wrong, you miss that much. So the teams, quickly decide how much you want to wager. We got all of it? All or nothing over here. Okay. So I'm going to do it, and then at least somebody on your team has to write it down. You need a spokesperson. Here's the category. I was supposed to give you that first, but you guys bid it all anyway. You want to change? Okay, Newton's second law. A proton and an electron are placed in an electric field. Does one undergo greater acceleration, and if so, which one? Don't shout it out. Discuss among your teams. One of you write it down so we know you're not lying. Decide your answers. Give you a minute. You're going to have to tell me who's your spokesperson. I didn't technically ask why. So at least you have a 50-50 chance, see? While you're deciding, those of you that came in later, here's your superhero papers you can come get after we answer this question. All right, do the teams have their answers? Okay, they're good. You guys come up with it. Do 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 do. Hurry up and choose your answer now. I don't know how long we'll wait. Okay, pick one. Got 5 seconds to write it down. 1, 2, 3, 4, 5. Your answer is? Electron, your answer is? Electron. You both get it right. Team 1 wins. Why? It has less mass. So it's accelerated more. Electrons are a lot smaller. Good job, guys.